supervisor modules. So we are looking at a supervisor module and it is half width. There are two supervisor modules and both of them have to be the same model. As you can see, now this has a 16 GB RAM, 64 GB SSD. So apart from that, it also has the console interface. It's based upon the Intel processor. There, the supervisor has connectivity with the system controller through which the line cards and the fabric modules talk to the supervisor. Okay. But one main function of the supervisor is that we know that it is a brain, and for high availability, we always require two supervisors, at least one in the active mode. And in Nexus, we have a stateful switchover from one supervisor to the another. What does this mean? A stateful switchover. We have the active supervisor, we have the standby supervisor. The runtime information, okay, the state information of all the processes is every now and then synchronized with the standby supervisor. So something happens to the active supervisor, the standby supervisor can immediately take position as the active supervisor and proceed with the process. So that is what is happening on the failure of a certain supervisor, or I must say the active supervisor. This is called as a stateful switchover. It provides high availability. Now let's look at the set of steps. So here, both the switches form an active and standby unit. Both are interconnected, and every now and then it is synchronized. Why? Because the runtime information is synchronized between both the supervisors. The active unit continuously synchronizes the state information of active connections and relevant protocols to the standby unit. This synchronization ensures that the backup unit has the latest information about the network state. So actually, we are talking about supervisors. It does not fail over immediately. So let's talk this way. Let's say this is soup 1. This is soup 2. Now we are going to talk about two failover conditions. One is, let's say there is OSPF1 running on top of the soup 1 at this point. Okay. And that information, runtime information, is synchronized with the OSPF process is synchronized on the soup 2. The soup 1 itself, it has something called PSS, persistent storage service. So actually, if you ask me where the supervisor saves its runtime configuration, it is saved into the PSS. Similarly, here also there is a PSS where this runtime configuration is now saved. We're talking about the failover conditions. One is failover of the process. So let's say OSPF failed. There is the system manager. Okay, another component called system manager, which monitors the OSPF, its runtime information, everything. As soon as the OSPF fails, system manager understands, okay, the OSPF failed. So what it will try is it will try to restart this process. Now, while it restarts the process, the new OSPF process will understand that the previous process stopped abruptly. Therefore, the new process will look for an existing runtime information. Yes. Where it will be on the storage service, like with a small database. So the new OSPF process will take that runtime configuration, the state information, and will become the same OSPF one again. If everything is okay with the PSS, sometimes the process could not be restarted, correct? At that point, the system manager may select to shift it to the other supervisor, because the runtime information is present here. So this is the failover of one process from one supervisor to another supervisor. The second thing is the failover of the supervisor itself. So we already know that the runtime configuration information, everything is mapped from one supervisor to the other supervisor. So when this guy fails, the SUP2 assumes an active role immediately, and it has all the relevant required information to do the switchover. So during that time itself, it can do the active packet forwarding and everything. It will handle that, and it will be able to handle the failover. During the failover itself, it will assume the active position because it has all the runtime configuration, state information, everything. When the SOAP one comes alive again, that is now going to be a redundant standby only. Okay, it's going to be redundant standby. Now, if you want, you can do the manual failover from the SOAP2 to the SOAP1. But by default, it is automatically elected. Depending upon, I don't know if it's called activation process, but give me a day. Tomorrow I'll come up with that process, what's happening on the election of the supervisor. Okay. So during the failover process, the standby unit assumes the active role and takes over the forwarding of traffic. So it makes use of that state information to resume all the active connections seamlessly. So, for all the features in Nexus, at least for most features in Nexus, we have this one called graceful restart. So when that is enabled, then automatically this happens. So the supervisor provides this biggest benefit, which is the stateful failover from one SOAP to the other SOAP. That is very important purpose of the supervisor. So your question, both redundant supervisors need to be of the same type within the chassis. The B plus is the high end with more cores and more thread. The RAM could be expanded. Okay, the RAM could be expanded. And as you see, so the same information is what I have put here also. So you have two supervisor models here for the Nexus 9K, and you have to have the same type within a particular chassis. Fan trace. So we know the importance of the fan trace. Now they are, who manages them? The fan trace are managed by the temperature sensor, which is even managed by the system controller. So the fan trays consist of smaller fans so as to provide a more efficient cooling and also more redundancy because it's hot swappable redundant trays. And as you can see, I have mentioned here the benefit of not having a mid plane because it doesn't block the airflow path. Therefore, we claim that the chassis has efficient airflow with no hotspots, and therefore less power and cooling is required. I actually took this from the Cisco document. Okay, so I believe them on this one. Okay, and because the smaller fans enable higher density, yes, more cooling and also more redundancy, and it increases the mean time between the failures because they claim the mid plane is not there. Yes, so that is the function of the fan tray. System controller. So I mentioned that some of the functions of the fabric, the supervisor are offloaded to the system controller. One is including the fan speed. The other one is the power supply management. And as you can see, maintenance of the out of band control plane. What is this? This is what we are talking about, the communication between the line cards to the supervisor via the system controller. So what exactly it is there are two things. One is this circuit chip, EOBC, Ethernet out of band control. Then the other one, Ethernet port channel something. So these are two chips. And what they facilitate is this out of band control facilitates the control plane communication, which is management communication. Then the EPC, again, a small circuit chip present on the system controller facilitates the data plane communication protocol packets. For the protocol packets, the line cards use the fabric modules. The fabric modules then send the packet via the EPC to the supervisor engine. So it's this way. Now you have the line card. Line card puts it on the fabric module. Fabric module uses the EPC to send it to the supervisor. What is the EPC? It is a chip sitting on the system controller. Okay. Number two, the EOBC chip. That's for the management communication. Now, that is also a chip sitting on the system controller, which facilitates the talking between the line card, the fabric module, and the supervisor engine. So the supervisor engine is managing the fabric module and the line card via that chip present on the system controller. So these are two main important functions that is facilitated by the system controller. Now, apart from that, this is something we already know. The system controller has to manage power and cooling. And to talk to those components, it makes use of this bus for the management. So this is another primary important function of the system controller. So like the supervisor here also, we have the active and the standby redundant system controller. But again, there is also, this is also automatic, how the system controller is selected. But again, there is a process here. It is the same process, very similar for the supervisor and the system controller. Okay.